All right, hello everyone. My name is Josh, and I'll be going over the list node problems today in the section video. I want to preface this before getting started. It's very important that you go visit Monday's lecture. From this week, it provides a very gentle introduction to how linked lists work and some review on reference semantics, which will also be really important. All right, let's start with the very first problem on our section handout, basic one. Actually, no, before I start on this problem, I think I want to spend some time talking about this very common bug you will see when doing these problems and feature on 143, that is no pointer exception. As the name suggests, no pointer exception deal with something when the variable happens to be null. Let's create something. So list node test is pointing at null. So now I've created a list node reference. Instead of pointing to an actual list node, is pointing at nothingness. It's pointing at null. Just having this line 5 here won't give me trouble. However, it's when I trying to look inside what the null variable is, trying to look inside the what test is, say by changing test.next is pointing at temp. This will give me a problem because test doesn't exist. It's not an actual list node. It's emptiness. So be very careful when doing list node manipulation problems that we don't want to change the reference. We don't want to dereference any empty node. We don't want to look inside anything that's not already present. All right, with that being said, let's now take a look at the spec. We have a before picture and an after picture. This is before, this is after. In the before, I have two lists. One is list is pointing at 1, which is pointing at 2, and temp is pointing at 3. And how I would get started is kind of redraw the example given here because I'm not a big fan of the drawing. Because I think it creates some ambivalence in where this list is pointing at, ambiguity. So let's draw this way. So I have the list on top and have the node 1 be on bottom of list. So list, as this kind of visualization suggests, is the node 1, and list.next, in fact, is pointing at 2. And of course, since there's nothing after 2, we'll point null after 2. Similarly, let's draw temp, which is just pointing at 3 and pointing at null. Cool. So now let's take ourselves away from the code a little bit. Let's see if we can only make changes to the arrows. How can we get 1, 2, null, 3 null to be 1, 3, 2? Well, maybe we want to change what 3 is pointing at. So instead of pointing at just null, we want 3 to be pointing at 2, which is the end of the after picture here. And how we can do that is by manipulating temps.next field. So temp.next, which is this arrow effectively, let's make it not pointing at 2, null, let's make it pointing at 2. And what is 2? Can we just say, I don't know, list index 1, like how we did in array list? Well, not exactly, because with linked list, we can only access the middle nodes from the front. So that is saying, oh, the front is list, and how we can get to 2 is with one arrow, and think arrows as .next field. So list.next. So how does that change our picture? Well, 3 instead of pointing at nothingness, it's pointing at 2. And since 2 happens to be pointing at nothingness, we'll just add here. So there are two 2's here, but they are actually the same node. All right, lastly, we want to change what 1 is pointing at. And what 1 points at can be referred as list.next. One list.next to be pointing at 3, and what 3 is, if we look above, is just temp. Okay, so this is gonna change here. And temp still points at 3, is pointing at 2, which is okay since in the spec it says we don't really care about what temp is referring to at the end. And let's mark. All right, boom, all tests passed. Let's think a little bit about this program real quick. What happens if we change what line 10 is, which is after line 9, to be before line 10? I'm sorry, before. So we swap the order of these lines. What that means is that we're going to change what 1 is pointing to. So 1 was originally just pointing at 2, This was the very beginning of this. So we're going to say list.next, which is 1, this arrow right here, have it point to 3 first. So 3. And we'll do this before having 3 point to 2. What will happen? Will this program still work? Well, let's think. If we change the arrow, which 1 was pointing from to away from 2 to be pointing at 3, we lose the only reference we have holding on to 2. Imagine that we have some paper clips holding onto each other. If we remove one of the paper clip to be clipping to something else, and that's the only reference we're holding on to, the paper clip will just drop to the ground. As in Java, it's the equivalent of saying we can't reach it anywhere. And we don't want that. We don't want that because 2 is needed in our after picture. So by swapping the order of the lines here, we lose reference to 2, which means the program won't work, as you will see here. This is important because we want to make safe changes to our list nodes. And safe changes is referring to if we change a reference that's pointing to something, say 2, we want something else, another reference holding on to it so we don't ever lose reference to it. Okay, now with that being said, let's take a look at advanced 1. So let's scale up a little bit. So the before picture, we have list is pointing at 5, pointing at 4, and pointing at 3. The after picture is saying, hey, let's reverse the order of all the nodes here. Was 3 in the beginning, and then 4, and then 5. So from approach to basic 1, we want to draw our pictures first. So we have list, and then we have 5, 4, and 3. Okay. Little different from basic 1, we're not given any temporary variables to start with. And just a gut feeling telling me that I can't really make any safe changes if I don't already have a temporary variable that's holding on to a node. So let's create one. List node temp point that to something. So there are a lot of choices where what I want temp is pointing to. So right now list is pointing at 5. I can have temp pointing at 4, pointing at 3. Since the beginning of the list node is 3, I think the best choice here is make temp pointing at 3. And how do we get to 3? Let's count the arrows. We get 1 here. We got 1 here. So that's 2 arrows from list. That's 2.next from list. Okay, let's update our drawing. So now temp is another reference we created pointing at 3. So we want 3, in the picture, we want 3 to be pointing at 4, and 4, and now 3 is pointing at nothingness. Let's change that. So temp.next is equal to list.next. So now instead of pointing at null, it's pointing at 4. So this is an interesting part. So note that 3 is pointing to 4, but this arrow is still here, which means there's a loop going on where 4 is pointing back to 3, which is pointing back to 4, and it keeps going on and on. Even though, so this phenomenon is called a a circular linked list. It's okay, but it can be very dangerous as you are easily able to get lost on which node you're sitting on. But it's okay because we're going to be really careful on how we're going to deal with this. So let's break this loop or change this circular linked list by having 4 instead of pointing back to 3. Let's have 4 pointing to 5. And we're able to do this because we have a reference to 3. We're not worried about losing 3 at all. And how we can do that is say temp.next, that's 4, and .next, that's 4th arrow, which is this arrow right here, to be pointing at list. Okay, so how does this change our picture? Well, it changes our picture quite a lot. So let's delete all this infinite list node stuff. So 3 is now pointing at 4. How do I want to do this? And 4 is now pointing at 5. So it seems a little weird that 5 is pointing at 4 and 4 is pointing at 5. And this does create another circular linked list, but it's now between 5 and 4s. And we want to break this. This is really confusing, and we want to have list.next, which is this arrow right here, to not point at 4. What do we want to point it to? Well, look in the after picture here, 5 is supposed to be pointing at null. So we can just change that to null. And again, I want to emphasize that we're able to do this because 4 is connected through 3. And voila, we have safely reversed the order of our linked list. Last thing I want to do is change list to be equal to temp, which is pointing at 3. List equal to temp. And we want to return a new linked int list here. So new linked int list, and have list as our head, as our front. Mark. All right. That's it for today's session videos. I would recommend going through Advanced 2 as well. These are really good practice for building up to kind of harder and more general list node linked list manipulation problems that will come on Thursday. Thank you for watching.